So after the super hectic last video, I hope you have made your notes and revised till the last hand-on formula topics till of multiple linear regression. And with that, let's start the today's video. So before starting, as you know, we will give our fun fact. So the fun fact for today is I think this is more logical. Animals can experience time differently from humans. Now you'll think why it's so. So the basics is to smaller animals, the world around them moves more slowly, and that's more logical. And compared to humans, for example, salamanders and lizards experience time more slowly than cats and dogs. This is because the perception of time, it's not physical present, it's our mental state. So the perception of time brain can process incoming information is how we see time moving around us. So if we are big bodies and if we are taking one step, for us it will take less time, but for smaller animals it will take more. So this fun fact was regarding that, and I found it very special, so I thought I'll share with you guys. So moving these things aside, let's start the today's topic, that is assumptions of linear regression. So till last one, in last one, in last so in last one of our videos, we saw that there was a rule that we studied, and this would be the assumptions which we would be following. So the first one we have is linearity. Second one we have is homoscedasticity. Okay. Third one we have is multivariate normality. Fourth one we have is independence. Fifth one we have is lack of multicollinearity. Sixth one is absence of endanglity. Okay. So now let's give the meaning for them. So linearity assumes that there is a linear relationship. Okay. So I believe this was the rule we were studying then also. So linear relationship between X and Y. Okay. Second one is equal variance. Third one we have is normality of error distribution. Okay. Next one we have is no auto correlation involved. Next one is no correlation in predictors, that is x-axis, right? The last one we read was no correlation in between predictors and errors. Okay, so these are few of the assumptions which we take in consideration while doing the linear regression models. And with that, we have completed our whole topic regarding linear regression, multiple regression. Fine. We'll move to a new form of regression model, that is ordinary least square regression. So make notes please. Common techniques for estimating coefficients of linear regression. One or more regression equation which describes the relationship between one or more independent quantitative variable and a dependent variable. Okay. Often evaluated using R square. Okay. So let's read it aloud. Ordinary least square regression. So it's a common technique for estimating coefficients of linear regression equation which describes the relationship between one or more independent quantitative variables and a dependent variable, often evaluated using R square. Okay. So if you are properly involved in research and other fields, you would already know what is R square value. But for newbies, I'll just tell you what's the meaning of R square. Okay. So in a definition, if I give a definition for R square, so it's an statistical, okay, statistical. So it's an statistical. So R square is an statistical measure in a regression model that determines the proportion of variance in the dependent variable that can be explained by the independent variable. So basically, this is a measure in that is used. So basically, R square is a measure used in regression models to determine the variance in dependent variable and the independent variable. Okay. And this ranges between mainly 0.00 to 0.9 something. Okay. 0.99 or something like that, because it's never perfect. So this is how R square value works. So now you know what is ordinary least square regression and also what is I square. Fine. I hope this topic's okay. I'll cover one topic more for you. So what is least squares? Let's study them also. Okay. What are the least squares? So it stands for minimum squares errors. That is SSE, standards for minimum square errors. And maximum likelihood and generalized method estimator are alternative approaches to OLS. OLS means ordinary least square regression model. Okay? So least squares it stands for minimum square error, that is SSE, and it has maximum likelihood and generalized method estimator for others alternative approaches to OLS. Fine. So that's all for this video, and thank you so much for watching. I hope you love the concept and you are making notes with it. See you in the next video. Bye.